Hey everybody, welcome to video 8-4B. This is the last video in Module 8. Sorry, faked you out there for the first part of 8-4. But we're going to wrap up the discussion of mid-segments from this lesson here by using the triangle mid-segment theorem. Okay, and so the triangle mid-segment theorem is just a formal statement of what we were just in the previous video proving with the coordinate plane math, and that was that the midpoints of two sides of a triangle is the segment joining those two midpoints is called the midsegment, as we know. It is always parallel to the third side and half the length of that side. So we're going to use that idea to find some missing measures in this triangle. In example 2, right here, we're being asked to find the length of UW in this diagram, triangle RST. Now, it doesn't actually say it, but just you may want to add this to your directions here, that it is safe to assume that U, V, and W are midpoints. There's no actual markings on the diagram to show that, so you kind of need to have that as a written assumption before you begin. Okay. So we want to find the length of UW. That's this length right here. Now, since U and W are midpoints themselves, that makes UW a midsegment. And so it's going to be, the length is half of the side that it is parallel to, the third side right here. Well, we're told that the length of ST here is 10.2. So it's going to be half of ST, or half of 10.2, or 5.1. For part B, we're going to find the measure of angle SVU. And so what we have below here is kind of like a two-column proof, just kind of like with the reasoning and the statement reversed. So what we're filling in is the reason. What is the reason that we can say UW is parallel to ST? Well, that's the triangle midsegment theorem. Because those are midpoints there, points U and W, then we know that the midsegment is parallel to the third side. That's what the triangle midsegment theorem says. Now, as soon as we know that those two segments are parallel, UW and ST, then we can assume that the measure of angle SVU, which is what we're being asked to figure out, let's put a little question mark in that spot right there, is going to be equal to the measure of angle VUW. Why is that? Because those are alternate interior angles. And if you want to know what it is that we're working with as a transversal, it's going to be with the length of UV as the transversal. So sometimes it helps to highlight, remember? Let's highlight these a little bit here. If UV is our transversal line and UW are the parallel lines, I hope you guys can see that our question mark angle right here and VUW, 41, are your alternate interior angles. So keep that in mind, okay? That's how we're able to make that. So we're going to substitute the 41 degrees for the measure of angle VUW in that equation, and so the measure of angle SVU is also 41 degrees. Let's look at our reflect. How do we know to which side of a triangle a midsegment is parallel? Well, that's pretty simple. That is always to the side that does not include the midpoints. So you're going to use the idea of alternate interior angles or possibly corresponding angles depending on which angle you're being asked about, but parallel lines are always going to come into play, and as are the 1/2 the distance of the third side for the midsegment length. Those ideas of the triangle midsegment theorem are going to come into play for you here as you finish up this work with your turn number 6, and also elaborate question 7 and also 8 on the next page, as we're working through some final questions with the triangle midsegment theorem. We'll see you guys next time.